Hi, everybody. I have a great guest with me on today, Adil from Psyonic, and we'll talk more about the upper limb and myoelectric hand market and where the ability hand fits in, talk about their startup journey, where they are now. They're looking into both prosthetics and robotics, which is exciting. But before we get started, just a quick little synopsis on calibration marketing. That's hosting this webinar. I started calibration marketing a little earlier this year, and it really came from a place of wanting to help smaller entities within O&P after being in this market for almost 9 years now and helping support the manufacturers that I had worked for from a product and marketing standpoint. I just saw this need within clinics and smaller and larger entities that just need an extra hand, whether it be through content or a project or what have you. And so that's where calibration marketing fits in. So anything from a project to a larger scale area of support that you need, you can learn more on calibration.marketing and see what we offer, along with some downloadables that are on there that are quite interesting that could suit you. But let's jump into our conversation today. Welcome, Adil. I'm not going to read this whole spiel. You can talk about yourself plenty. And as we joked, I feel like this hand is a part of you now, and you are tri-manual. So you started Psyonic while you were still in college, or at least the idea behind Psyonic started when you were in college, and it started off as just a group of your schoolmates and friends, and now you're slowly taking over the world. So if you could share a little bit more about how all of this started, and without getting into the weeds, because we'll address some of that, where are you guys now, and what is all of this? Where are we? What does it mean?
Yeah, absolutely. Thank you for having me, Linda. And so yeah, I've wanted to build bionics basically my whole life, ever since I was 7. My parents are from Pakistan. I was born in Chicago, but I was visiting Pakistan, and that was the first time I had met someone with a limb difference. And she was my age, missing her right leg and using a tree branch as a crutch. And that's what inspired me to go into this field. So I went to Loyola Chicago for undergrad, got a bachelor's in biology there, a master's in computer science. Taught there for a couple of years, went to the University of Illinois at Urbana-Champaign, got another master's in electrical and computer engineering, PhD in neuroscience, and they left medical school.
Just a couple things, on the list.
And so while I was doing my PhD, we started to 3D print like our first prosthetic hands, and we'd started with open source designs that we found online. There was like a common one that many engineers start off with is this humanoid robot called InMove. It's by a French designer, Gaël Langevin. And it's like this entire humanoid robot that you could build for like $1,000. Huh. And we modified it so it was just the arm. And it was me and like a couple other students that were in a robotics lab at the University of Illinois under Professor Tim Brettel. And we actually did myoelectric control on this. And this was back in like 2013, 2014. So about like 11 years ago that we were doing this. And this is when like 3D printing became like really big on the consumer side, right? And it really opened up access to be able to like prototype these devices, and so like we didn't have to do these expensive like injection molding techniques that were really prohibitive to us starting to jump into this field. And so we kept iterating on those designs. We had our second version was actually based off an early Open Bionics open source design called Dexterous, and we modified our own electronics in it, our own machine learning algorithms, and then the next 3 versions of the hand that we designed ourselves from scratch, and we call those Mark 3 through Mark 5. We open source those, so anyone can go online and find the instructions.
Oh, very cool.
Of the hand, and so yeah, kept iterating. This latest version that I'm holding here, this is Mark 9 of the ability hand. So it's gone through 9 iterations of just starting basically from scratch entirely, just based off of like feedback that we got from clinicians, so prosthetists, as well as potential end users as well too. And the coolest thing is that it's always getting better, right? Like what we'll have like 2 years from now is going to be like way better than anything that we have now. And then this hand is like way better than anything that we had like 2 years ago, right? And that's what keeps this field so exciting.
Yeah, no, and it's, I think the fact that you're on version 9 speaks to what sometimes is overlooked in the startup world, right? That it's going to take a tremendous amount of time to get to, especially in the upper limb prosthetics and myo world, to get to a product that is going to be viable and that is going to be accepted and that is going to be covered by insurance. And so like all of these things, like it's not just well, hey, we made this, it's selling over there, it's working great, let's go to another country or market or whatever, and it's going to work fine. And I think, that's what a lot of that's a lot of the pitfalls that happen to a lot of startups. So it'd be interesting for me, certainly, and anybody listening in, and by all means, for those that are listening in, ask questions. If you want to enter your comments, we'll try to answer as many as we can. But if you can kind of walk us through, I know you touched on where you guys started, right? But once you kind of got going and said, oh, this is a real thing, let's really put some larger efforts and funding behind this, because obviously I think a lot of us have seen that there's been a lot of funding rounds and things like that. What does your startup journey look like? What has been, and then to follow that, what has been the biggest hurdle thus far and the biggest learning? Because I think there's a lot of things, as I have these conversations, there's a lot of similarities, but there are certainly nuances to each startup.
Absolutely. Absolutely. And so, my original plan was to actually finish an MD PhD and work at an academic hospital. And then I'd run a lab. And so, the Center for Bionic Medicine at Shirley Ryan Ability Lab was always like one of my top goals. And I got to do a couple internships there with Levi Hargrove and like Todd Kuiken's group.
Nice.
And it was an incredible experience. Right. And so there was a trip that we made in the summer of 2014. So we got in touch with a nonprofit group that many in the community are aware of, the Range of Motion Project.
Yeah.
And
okay.
Their mission is to provide prosthetic care to those who can't afford it in the U.S., Guatemala, and Ecuador. And they have plans to expand to Latin America and things like that. And the co-founder of that organization, David Krupa, he is an alum from the University of Illinois as well. And so we got in touch through some students that he was working with over there. And he was able to arrange for me and another student to go down to Ecuador when we were on Mark II of the ability hand, right? And have a patient actually try it out. And we'd never tried this on an end user ever before. We'd only hooked us ourselves up to EMG electrodes and tried it there. So we were just like, this is an incredible opportunity, and B, this is going to be really crazy because we've never actually done this before.
Yeah, right.
And that was basically the beginning of 2 weeks of all-nighters, and when we went down to Ecuador and trying to get this hand to work. But our first user ever, Juan Suquillo, he had lost his left hand in a landmine explosion 35 years prior. He was in the Ecuadorian army, and there was a border war between Ecuador and Peru. And he, in front of international news stations, had said that he felt as though a part of him had come back. And that was because he had made a pinch with his left hand for the first time in 35 years. And the hand at the time was goosebumps. And the hand, it was 3 times the size of an average adult human hand. It wires going everywhere, pulling their breadboards, power supplies, the wall. But for him to say that, I mean, he had forgotten how to make a pinch with his left hand, and we had to retrain his brain by placing a mirror in his amputated side, reflecting his right hand, tricking his brain into thinking it was there. And that's when I realized that if I stay in academia, then this just ends up as a journal paper. If we want everyone to feel the same way that Juan did, we had to commercialize this technology. And that's when Psyonic was born. So things shifted from this kind of this academic lab mindset to how can we commercialize this? How can we start building an actual product, get a sales pipeline, make a business model, and make this sustainable so that we can actually make the most impact possible in a way that you can't necessarily do from a strictly academic standpoint. And one of the most salient things that was or pieces of advice I was given too was that I had to make a decision at some point whether to finish medical school or to go like, all in with the
Rogue. Yeah.
and leave medical school. And it was my physiology professor, Dr. Kashif Ahmad, my M1 physiology professor, who took me out to dinner, and he was like, Adil, with if you become an MD, the impact you will make is very important, but it'll also be very local to wherever you practice. What you can do with Psyonic, that can have global impact. And that really sat with me, because that was the idea, right? How can we make the most impact possible? And the goal has always been the same, regardless of whatever path I had chosen. It was to build the most advanced bionic hands and make them accessible to both humans and robots. And it was just the way we do that changes, right? So we do it in the lens of a startup as opposed to an academic research lab. And we still publish papers. I think we had like a year or two ago, we got a couple of papers in like Nature Electronics and Nature and things like, and Science. And so we still have that research bent, and that gives us a lens into kind of where this technology is heading into the future. But everything that we do is driven by actual user needs. So if we don't see an actual like practical benefit to the end user, it's not a line of research that we will actually really go down.
Sure. No, and I guess I was going to stop you right there. Why? I mean, obviously, I understand the desire to go down this path of bionic hands, right? And due to the history and the kind of research that you did with it, but obviously, as you and I both know, like, it's such an oversaturated market. Yeah. Why continue to go down this particular path? What did you see? What did you feel like was missing, that you felt like was not being addressed, and that the ability hand could address? I guess outside of the fact that you wanted to make it more accessible and affordable to those that need it.
Yeah. And when we first started like building these hands back in like 2014, 2015, it wasn't as oversaturated, right?
I mean, no, it was not. It was Touch Bionics and Be Bionic, and I was in that world, and I'm like, oh, this is great. Just two competitors.
Exactly. And then it was around that time that Tasca was starting, we were starting, Open Bionics was starting, right? And then I would say like that was kind of like a second wave, and then there's the third wave of a bunch more coming out, right? Like with Adam's hand from Bionit, and like Zeus, and like the Genesis hand,
Zeus and everything,
Yeah, and so there were a bunch of things that we were looking at in particular. And so the thing is with lower limbs, even though there's like potentially 5 to 8 times as many people with lower limb loss than there are with upper limb loss, the control that you could get from like a Genium or an X3 or a C-Leg was good enough, right? Like that it didn't need that kind of like huge change in like a paradigm shift in what was out there. And I think now given some of the new technology that's coming out there, especially with like osseointegration and things like that, I think there can be a paradigm shift in lower limb as well too. And we're interested in making an ability leg in addition to an ability hand.
Very cool.
But at the time, like hands, like, and at some level still, like hooks are still the most prevalent prosthesis on the market. And one of the big reasons for that is the proprioception that it gives you, right? You know exactly where your shoulder is. You know exactly how open and closed that hook is in a way that a myoelectric device can't give you yet, right?
Right. But it's awful cumbersome.
Exactly. You have to use your shoulder. You have to wear the shoulder harness to do it. You have to use your shoulders to control the end effector on the end. So there's pros and cons to using like a body powered hook, but there is a lot of cons to using a myoelectric device as well too, right? They're heavy. Like the control strategy isn't necessarily there as well too. And so it was a really big opportunity for us to, like you were mentioning, make things more accessible on that front, as well as make things more accessible on that front, but also kind of push the boundaries of what's possible with upper limbs in a way that hasn't been really taken advantage of, right? one of the big ones was sensory feedback. We'd seen a lot of research going into actually giving touch feedback to users and the benefits that can have in terms of like actually making the hand feel like it's like embodied by the user, as well as like just being able to grasp really delicate objects without crushing them, right? Like a raspberry or like a screw, or like we have that little
that's huge,
right? And so a lot of my research during my PhD was on sensory feedback mechanisms for upper limb prosthetic devices. And so we wanted to build like prostheses for doing that kind of research that had touch sensing capability built in, because there was no hand out on the market yet that had touch sensing in it. And as we kept like iterating on those designs, like we felt that we could build something that was robust, that could actually work out in the market for people with touch feedback. So that was one of the things. And then another thing was the speed with which the fingers move, right? So that was like a very common thing that we heard from users, is that they just have to sit and wait for their like hand to open and close. And so we wanted to build something that was really responsive, that would actually, like, when they close it, it just like immediately would react to their input. So we wanted to build the hand to be super fast, to be touch sensitive, have touch sensing capabilities. But then on top of that, we wanted to make the hand super robust. That was one of the big things, because a lot of our potential users, when we were doing like these calls with clinicians, patients, were just saying that, you know, they didn't want their hand to break very easily, right? And they were finding that was causing a lot of issues for them, that they would get hands to break really easily. And so that put us in kind of like an interesting situation, because if we built a like purely 3D printed hand, and especially at the time, right? A purely like, you know, ABS or PLA printed 3D printed hand was going to be too fragile for people to use, right? And so, but it really reduces the cost in making something. So it's like, how can we still leverage the low cost of 3D printing, but make this hand still like more robust than anything else that's out there? And there was a group out of Yale, the Grab Lab, Dr. Aaron Dollar's group, where they put together this soft robotics toolkit on like how to build like soft robots. So instead of making like your like joints and your links out of rigid materials like injection molded plastic or 3D printed plastic or metal or things like that, you'd make them out of soft materials that are kind of like akin to your own natural hand, so like rubber and silicone. And so what we would do is we would 3D print a mold and then inject silicone into that mold, and then you get these flexible fingers that, you know, you could smash these things and they would just flex out of the way and come right back to their original position. And so we kept iterating on those designs, and we found something that worked. And that's why, you know, when I squeeze these fingers together, they flex that way. And I can smash this, it totally survives. And you might have seen in some of our videos, I've dropped it from like the roof of my house, thrown it in a dryer, flaming board breaking, things like that. We wanted to show that we're okay with our users, you know, not having to, you know, be super careful about. Obviously there are limits, as there are, like, these hands can't heal themselves the way that a natural hand can, right? But it doesn't need to just, like, you know, sit on a shelf or like be handled with like, you know, gloves. We want people to actually try and do things with them, like go out golfing with it, or like or paragliding, or you know, as well as your just normal activities of daily living, right? Like making breakfast or doing laundry and things like that.
Yeah, no, and I think that it certainly speaks to, because I know you and I have had conversations leading up to this, and over the years when you guys started to come on the scene, kind of I was always saying, like, okay, it certainly proves the point of throwing the hand into a washing machine or setting things on fire around it, or showing how robust it is. And when my husband saw those videos, he was like, oh my God, that, like, I get it. I get that. And so, like, for others of us in the field, I'm like, oh, but where are those ADLs? So, like, I'm also super stoked to see those videos now coming out for your Tuesday tips, which I think a lot of people can utilize as they're learning the hand. But hearing you explain the thought process behind doing the earlier videos makes total sense to me. That, you know, there's only really one way to show robustness, instead of just saying it's robust.
Sure.
you know, really show what it can take on. And I agree, you know, a lot of the time there is a high rejection rate in upper limb, and it's for a variety of reasons: socket fit, no OT.
Yeah.
But a lot of that is also due to the fragility of these devices. And it's, you know, it's critical to show users that they can go about their daily lives and not have to worry about damaging it or going out in the rain and forgetting their umbrella or something like that. So I think you certainly did that spot on. Um, but I guess, would you say that trying to figure out how to go to a lighter device was one of the larger challenges thus far? Because it certainly sounds like it.
Yeah, definitely, you know, that was kind of like a big pivot for us too, because because we thought we were going to like 3D print the whole thing, right? Before
Yeah.
the beginning, and then it was just like when that the robustness thing and like things like weight and like all those other factors
Yeah.
were coming in, and cost, we were just like, how are we going to retool basically this entire thing? And so if you ever come and visit us in San Diego, it's like
I would
it's a lot of
love
fun
to. Yeah.
in our lab, and you're more than welcome at any time. But in our lobby, we actually have like all of the iterations, right? We call them Mark 1 through Mark 9 in glass cases, and then you can see like between Mark 4 and Mark 5, there's that huge jump where we started incorporating like the silicone into the hand as opposed to just having the entire thing 3D printed.
Yeah.
And that was like, it was just a direct result of just us having to like, you know, kind of reformulate the entire way we were approaching building these hands. And yeah, it was definitely one of the biggest challenges, and in order to make it at a, you know, a price point that we could
Right.
under like a standard L code and things like that.
Right. Yeah, which I think, you know, and we'll touch on Shark Tank for a second, because I think when you address the cost to make this type of device, which all of us in the industry know what it is, and then the cost that we sell it to the clinic, from a user perspective that typically does not see that kind of the margin that goes into it, it is jarring, right?
Yeah.
But knowing, and I think that there continues to be work done from that standpoint from the likes of you and other manufacturers to see how do we make this less expensive all around, right? But I think what is not considered, other than what feels like, oh, well, they're just getting a fat margin, is that on the one side, you guys need to get paid for all of the innovation that you're putting into this. And then that's, you know, whatever the clinician buys any one of these devices, they also need to get paid for their time. So they're obviously going to mark that up X amount to insurance. And so that's why we're talking about 40, 50, $60,000 hands, because they're only getting paid one time.
One time, exactly. So any support requests that end up happening, or any like follow-on visits, they're not getting paid for that.
Right.
We're not charging for support on our end either. So it's that definitely goes into it as well, and also just the volume, right? I mean,
Right.
like there's, I think for like multi-articulated hands, like total, like every year there's probably like a couple thousand that are sold like globally, maybe low 10,000s or something like that. I mean, but you talk about like mass manufacturing, like compared to like an iPhone, you're talking about like hundreds of millions of those, right? And so it's this huge difference between like just these volumes that occur, that if you need to, like, if you're trying to build a business around this, then it's economies of scale, right? So if the volumes are lower, then in order to survive, then the prices are going to have to be higher. I mean, and that's actually one of the reasons why we're actually looking into kind of the robotic space as well, because if the volumes there are going to be as high as a lot of the companies are saying they are, like, you know, the tens of thousands of humanoid robots coming out and things like that, you multiply that by 2, and that's however many hands you need, then we can actually use that as a driver then to also bring down the price for these devices. That's
fair.
Too. And so that's one of our ways that we're looking at accessibility as well. So if we can get this price down to maybe even a point that Medicaid can cover, and that's potentially one of our goals, then I think we're going to have something really special there.
Yeah, no, and you guys really jumped into the robotic space, I think, head on and early on, and tried to kind of, find where obviously a prosthetic hand is a prosthetic hand, regardless of what you try to fit it on. The intention is the same, right? Whether it be human or robot, is that you need that dexterity. And
Yep.
so it's been interesting to kind of watch you guys walk that line of where, is it primarily prosthetics? Is it primarily robotics? Where, and I understand from a manufacturer standpoint, again, like the need is in both places.
Mhm.
So it's where is that volume that can allow you to do more in
Yeah.
in this case across the board.
And it's interesting on that front too, because um, the roboticists, they're trying to have their robots do human tasks.
Of
And
course,
the
yeah.
interesting thing about the prosthetic space is that we've optimized it for
Hmm.
humans to do human tasks with a prosthetic hand. So it makes sense that if they're trying to achieve the same thing, that they would use the same tool at the end of the day. And it's really one of the most fun stories I have too, is that when we went down to NASA last year, so NASA
Yeah.
had our hand on their humanoid astronaut robot Valkyrie, and they were doing like tasks that astronauts would do manually on the International Space Station, for example. And they were showing that like they have all these buttons and panels and knobs and switches and things like that, but they were struggling to do a zipper that was on the wall. And so our
Mm,
user experience specialist, Annika Berlin, she was with
yeah.
us on this trip, and she walks up to that zipper and like easily does it like using a key grip. And the NASA engineers were just like, we didn't even think about using the hand in that way, right? And so it's
Hmm.
like there's a lot to be learned on the robotic side from the prosthesis users, and the advancements that are made on both sides are very symbiotic, right? So if we like all the like a lot of the things that people on the robotic side have been asking for, like extra sensing and like maybe extra degrees of freedom, are all going to be beneficial to the prosthesis users, as well as the things that the prosthesis users are asking about, like robustness and like sensation and things like that, are also
Hmm.
the same problems that need to be solved on the robotic side. So it's
Interesting.
very
Yeah.
symbiotic on that end.
No, and it's interesting that you say that about key grip, is that it's one of the things that a user learns in OT, right? Because it's not something that's intuitive, because we don't do that with our sound hand. And so it's interesting to see how on the NASA end of things, those roboticists did not recognize that either. And sometimes that's the downfall when you are trying to use prosthetic hands, regardless of what the application is, right? And so that's
Yeah.
why we always talk a lot about that critical OT component and understanding how these devices function.
And
Uh,
one of the most popular grips on our hand is actually this one right over here, where it's we call it the power key grip, or power/key grip.
okay,
You can do your standard power grip, but just by sliding the thumb back and forth, it switches over to the key grip. So
which is
you don't have
so
to do like a
easy.
trigger. You can literally just knock it against like your knee or whatever, and then
Yeah,
move it over. And our users have found that incredibly, incredibly helpful to just switch between doing like a key grip for precise things, or a cylinder grip, like a power grip,
right.
mugs and cups and like handles and things like that.
Right. And so let's have a little bit of fun. So I know you're in San Diego, I'm in the Boston area. And regardless of where you are in the world, you can make the hand work through your app, right? And have it do a wiggle or, whatever kind of gesture you want. So if we could do that and show the audience what the capabilities are, and then just kind of talk through what the possibilities are. Where am I? Can
Yeah.
you see my hand?
Oh, yeah. Let's see if I got. Yep, I got it right there, I think.
Okay.
And then if you bend your pinky, or like, yeah, you can do individual fingers too. Yep. So yeah, you're all the way over in Boston right now.
Yep.
I'm in San Diego, and you're able to control each of the individual fingers on this hand.
And so, like, other than initially, like when you see this, you think, "Oh, that's fun." When is this actually going to be applicable? But I know you've spent some time looking into and learning about implantable electrodes, and so like what does that look like? What does the future look like for this type of technology?
Yeah, absolutely. And so it's one of the reasons we actually moved to San Diego a couple of years ago. And so we were in Champaign,
Mm,
Illinois, and we moved to San Diego primarily for a lot of reasons. But there's a lot of resources here, including the military hospital, including the University of California, San Diego. So I'm affiliate faculty there in bioengineering. But also the Challenge Athletes Foundation is 15 minutes away from
yeah.
us. There's like the entire like entertainment industry in LA.
And the kids love it.
And the yeah,
Just down the road.
the weather cannot be beat, right? So I mean,
Yeah.
it's that's for life quality reasons. I mean, it's a great reason to
Yeah.
come out here as well. And so one of the things that we're doing with like Dr. James Flint, who's a orthopedic surgeon at the Navy Hospital here, as well
Hmm.
as Dr. Kate Hinchcliffe, who's a hand surgeon at UCSD, is we're working towards the next generation of these bionic devices, where instead of having like the surface electromyography sensors, the muscle
Yeah.
sensors on the outside of your body, we would implant them directly into your nerves, right? And then that would be coupled with osseointegration. So many people are familiar with like EOPRA. It was similar to doing EOPRA, but with
Okay.
implanted intraneural electrodes as well too. And we've got many partners that we're collaborating with to make this happen as well. And so one of the big limitations that we've seen with surface electromyography is that you can only really do pre-programmed grips, right? Like you can do a power grip,
Hmm.
you can do a key grip, or
Sure.
you can do a pinch, or you can do like, the gestures like rock on or whatever, right?
Yeah.
But you can't really do that individual finger control that you were just demonstrating, like
Hmm.
in the
Right.
camera, right? And that's where we want to head with this technology, right? We, with all these advances in like deep learning and like foundational models that are happening on like the robotic side, a lot of that can be applied to neural data directly. I mean, like even Facebook has been doing a lot of cool
Mm.
stuff with like the remnants of like the thalamic myoband that had come out like many years
Sure.
ago.
Yeah. Yeah.
Labs, and then Control Labs was absorbed by Facebook or Meta, and then they're doing some really cool stuff over there with a lot of algorithms. And
Hmm.
so combining that, like all of those different things together, I'm hoping that like in a couple of years that we might have our first users like really accurately playing piano and smoothly playing piano or typing
Mm.
keyboard in a way
That'd
that
be
wasn't really
huge.
possible with like things like pattern recognition and like classifying different grips in the past. So on the robotic side too, I mean, you just teleoperated the hand across the U.S.,
Right.
right?
Yeah.
Imagine
Hmm.
doing that for space. You can imagine doing that for robotic surgery or like a humanoid robot or things like that. So there's applications again on both the robotic side and on the human clinical side as well.
Yeah, and so I mean, you're a busy man, and you guys were just at Comic-Con. You had somebody over at the Amputee Coalition. You're going to Hangers Upper Limb Symposium in Florida. There's a cat or Amputee Coalition in AOPA. Where, other than NASA and the beach, where I mean, because also those boxes are checked. Where, like, what do you feel like you haven't done that you're like just chomping at the bit to be at? Or it's okay if you don't have the answer. I know it can be a big one. Maybe it's going to the moon yourself or Mars and just operating those robots from here even.
Honestly, like I cannot wait to get a hand up on the ISS or like whatever the
Mm,
next space station is going to be. I think that's going to be really, really exciting on that front.
yeah, that
But
would be cool.
yeah, I mean, a lot of like this like Aussie integration stuff that's happening in Sweden and Australia. I mean, like I think those are, it's really cool to see like hotbeds like globally like appearing for like just really pushing the boundaries on this stuff. So I'm excited about what's happening on those fronts and being able to
Hmm.
travel to those places too.
Yeah, for
And I
sure.
got to go to Australia last year. I haven't been to Sweden yet though, so I mean, I think
Mm.
that would be kind of fun.
Yeah, I'm sure it'll happen. But before we wrap, is there anything that you guys are obviously in growth mode and all of this, it's all just really taking off for you guys. But is there anything that whether it may be a potential user that's listening or a clinician or, a startup, somebody in just starting out in this market or curious about it, whatever the case may be, is there something that you want to leave them with that we haven't touched on and that maybe comes up or doesn't come up enough that you wish was talked about more or that you
Yeah,
had a chance to address?
We've actually started a new initiative with it's a partnership with Limbs for Life actually, and so
Okay.
a nonprofit to help um, uh, provide funding for people who can't afford like prosthetic
Hmm.
limbs. And primarily, they function as doing lower limb prostheses in particular. But with this new partnership through our subsidiary called the Psyonic Institute,
Okay.
we created an ability fund where people can actually donate for people who are underinsured or uninsured to get our prosthetic hand. And it's actually for every $25,000 that's donated, it'll fit an entire prosthetic hand, so including all the clinician's fees and everything, but
Awesome.
also a leg.
Oh,
So an arm
wow.
and a leg for 25K. And so this is a brand new initiative. We'll probably be making like a more formal announcement about it in the next couple of weeks and everything. But
Oh,
it's really exciting in terms of getting like making the hand accessible and making prostheses accessible in general. And that's what we've always been about, making the most advanced
right.
prostheses, but making them more accessible than ever too. So that's something that we're super excited about in the
Oh,
future,
yeah.
as well as just it's really exciting to see where all this technology is heading, not even just from us, but like from all of the
Hmm.
other like prosthetic limb manufacturers, both on upper limb and lower limb, and people who are doing osseointegration, implanted electrodes, the other hand manufacturers. The future is going to be very, very exciting, and it's a really awesome time to be in this space with just everything that's going to be coming out in the next like 3 to 5 years.
And then I think it's great that you're opening this up to your local community, right? Because you have those open houses that you do and just educating more people about the advancements that have been made. Because I know when I came into this almost 9 years ago, I had no idea that at that point the ILM was even like that was a reality.
Sure. Yeah.
No idea. And a lot of people that kind of fall into this through work or a traumatic incident don't know that either, right? So I think it's great that you're opening that conversation up and just teaching more people about the possibilities that are out there. So it's kudos to that. So I know you guys are doing a lot. So thank you for your time. I know you've got some airplanes to jump on, some, stuff to do. Um, but before we leave everybody, we have two more series coming up, two more guests coming up this summer. The next one is Elevate Movement at the end of this month before we all head off to AOPA. And then we have one more, and that'll wrap things up. But Adil, thank you so much for your time today. And thank you for anybody listening in. You can always learn more about Psyonic on psionic.io or reach out to Adil on LinkedIn and just inquire. I know you're always ready to answer any questions.
Absolutely. And thank you for having me again, Linda.
Oh, yeah, for sure. It was a great discussion. So hopefully everybody took away a few nuggets on the various topics that we covered. But thank you for your time, and we'll see you again soon.
Awesome. Take care.
Okay.